Evening everyone, I'm Reshma Priya from CSC ML Department C section. Today our course title is Ordinary Differential Equations and Vector Calculus. Today I have taken a topic named Homogeneous Equation in Electrical Engineering. Coming to the courses and outcomes, there are three types of course outcomes. First one is Understand Homogeneous Differential Equation in Engineering System. Students will be able to explain the fundamental concept of homogeneous differential equations and their role in modeling electrical engineering systems. Coming to the second one, Apply Homogeneous Equation to Electrical Circuit Analysis. Student will be able to apply homogeneous differential equations to analyze the natural response of electrical circuits such as RL, RC and RLC circuits. Coming to the course outcome 3, analyze electrical system behavior using mathematical models. Students will be able to evaluate electrical circuit behavior by modeling current and voltage changes over time using homogeneous differential equations. Introduction. Electrical systems are often describing using mathematical models. Differential equations helps engineers understand how electrical quantities change. Homogeneous equations are an important type of differential equation. They are commonly used to analyze electrical circuits. These equations help describe the natural behavior of circuits. Differential equations help engineering understand how electrical quantities change. Homogeneous equations are an important type of differential equations. They are commonly used to analyze electrical circuits. These equations help describe the natural behavior of circuits. Electrical systems are often described using mathematical models. Differential equations help engineers understand how electrical quantities change. Role of mathematics in electrical engineering. Mathematics helps engineers analyze and design electric systems. It provides tools for solving complex engineering problems. Circuit analysis often involves mathematical models. Differential equations are widely used in electrical engineering. They help in predicting system behavior over time. Circuit analysis often involves mathematical models. Mathematics helps engineers analyze and design electrical systems. Differential equations are widely used in electrical engineering. It provides tools for solving complex engineering problems. What is differential equation? A differential equation is an equation that involves a function and its rate of change. It describes how one quantity changes with respect to another. In electrical engineering, it helps represent relationships between voltage and current. It is used to model real-world systems. Differential equations are essential in dynamic systems analysis. Types of differential equations. Differential equations can be classified into different types. Ordinary differential equations, partial differential equations, linear differential equations, nonlinear differential equations, homogeneous equations, non-homogeneous equations. Each type is used for different engineering applications. Homogeneous differential equation. A homogeneous equation is a special type of differential equation. In this equation, all terms involve the dependent variable or its rate of change. There is no independent external input in the equation. These equations describe the natural behavior of systems. These are commonly used in circuits analysis. Identifying homogeneous equations. Homogeneous equations can often be recognized by their structure. The equation depends on the relationship variables. The term usually have similar degrees or forms. Engineers use specific techniques to identify these equations. Once identified, they can be solved using standard methods. Method of solving homogeneous equations. Homogeneous equations are solved using substitution methods. The substitution simplifies the equation. The simplified equation becomes easier to solve. After solving, the original variables are restored. This method helps obtain the final solution. Example concept. Engineers often apply homogeneous equations to practical problems. This equation helps simplify complex relationships by applying substitution methods. Solutions became manageable. Understanding the concept is important for circuit analysis. Electric circuit fundamentals. Electric circuit contains basic components such as resistors, indicators, capacitors. These components control the flow of electrical energy and create relationships between current and voltage. Natural response of circuits. Natural response occurs when an external power source is removed. The circuit behavior depends on stored energy in components. Energy stored in inductors and capacitors drives the circuit. The current or voltage gradually decreases over time. Homogeneous equations helps describe this behavior. RL circuit. An RL circuit contains a resistor and an inductor. The inductor stores energy in a magnetic field. When the power supply is removed, current begins to decrease. The rate of decrease depends on resistance and inductance. Homogeneous equations are used to analyze this process. RL circuit behavior. The current decreases gradually rather than instantly. The energy stored in the inductor is released slowly. This process is called the transient response. Engineers study this response to design efficient circuits. RC circuit. An RC circuit contains a resistor and a capacitor. The capacitor stores energy in an electric field. When the capacitor discharges, voltage decreases gradually. The resistor controls the rate of discharge. Homogeneous equation help describe this behavior. RL circuit behavior. The capacitor releases stored energy slowly. The voltage across the capacitor reduces over time. This behavior is used in timing circuits and filters. Engineers analyze this using homogeneous equations. RLC circuit. An RLC circuit contains a resistor, inductor and a capacitor. It combines properties of RLC and RC circuits. Energy transfers between magnetic and electric fields. This circuit can produce oscillations. Homogeneous equations are used to study these systems. Types of RLC circuit responses. Depending on circuit parameters, the response may be oscillatory response, fast return to equilibrium, slow return without oscillation. These responses are important in communicating systems. Methods to solve homogeneous equations. Common solving techniques include substitution methods, separation of variables, characteristic equation methods, transform methods. These techniques help obtain solution efficiently. Graphical representation. Solutions of homogeneous equations can be represented graphically. Graphs help visualize current and voltage changes. Some circuits show gradual decay curves. Others show oscillating responses. Graphs help engineering interpret circular behavior. Electrical interpretation. Homogeneous equations help explain current decay in inductive circuits, voltage decay in capacitive circuits, oscillations in RLC circuits, energy transfer between components. Practical applications. Homogeneous equations are used in many areas. Power systems, electronic circuit designs, communication systems, signal processing, control engineering. Advantages. Helps analyze circuit behavior mathematically. Useful for understanding transient responses. Helps engineering design stable electrical systems. Improves accuracy in circuit analysis. Limitations. It describes only the natural response of these systems. It does not include external inputs. Some problems require complex calculations. Summary. Homogeneous equations are an important concept in electrical engineering. They describe natural responses of circuits. RL, RC, and RC circuits are key examples. Understanding them helps engineers analyze electrical systems. Homogeneous equations are an important concept in electrical engineering. They describe natural responses of circuits. RL, RC, and RLC circuits are key examples. Understanding them helps engineering analyze electrical systems. Conclusion. Homogeneous equations plays a crucial role in circuit analysis. They help engineers understand how electrical systems behave over time. Their applications extend many areas of electrical engineering. Thank you.